In today's video, I'd like to show you how I made these 3D printed PCBs using Kicad, Fusion 360, some copper foil tape, and a 3D printer. For prototyping circuits, typically I do this on perf board, or maybe even copper clad. And this can lead to busy, complicated circuits. They're not always the neatest builds. Troubleshooting can be hard. So I wanted to come up with another way. Now, of course, in the past, I've made a lot of PCBs, and these are great when you have your idea nailed down and ready to finish, or maybe you iterate on some PCBs. An alternative to using perf boards or PCBs, for high power electronics, you can use copper foil and simply stick it to plastic to make a copper clad board, and then this can be cut away using a razor blade. You can also do the same thing with copper clad by using a Dremel to remove material in the areas you need it. An example of this being done is for my full bridge for my QCW coil. And you can see down here, this is a piece of plastic with copper foil on it, and it's been simply just cut away on the top side and back side, making all the connections necessary. The buck converter was also constructed this way as well. So all the copper foil, as well as the capacitor bank, and another kind of miscellaneous project. But as you can see, this is pretty messy and there's not really a clean way to cut these complex shapes. To create our board, we're going to be using two main programs today, Kicad as well as Fusion 360. I have a demo project loaded here in Kicad. This is just a basic blinking LED circuit. I've gone ahead and assigned the footprints to all the components, so I can go ahead and open it in the PCB editor. Here's the PCB I created for this demo. A couple things to keep in mind. Trace width needs to be at minimum 2 millimeters. Any thinner, and this can be very difficult to not peel the copper tape off when you're cutting it away. We want to add extra clearance. I've gone ahead and kind of spaced these out a little bit so that the trace isn't too close to the pads for the components or the other traces. We want to make sure that we're routing on the back copper layer, which is represented by this blue here, instead of the front. And finally, I've adjusted the through-hole pad size for all these components to 1 millimeter. My printer is calibrated to print small holes well. However, it can be difficult if your printer isn't set up like that, and you might need to add extra clearance in the slicing software, or you can just make these holes a little bit bigger. To get this into Fusion, we want to go up to File, Export, Step. By default, export components might be checked. We want to make sure that is disabled. And next we want export board body and tracks and vias as well. Going to want to select where this file will be exported to and then press export. Now we can open up Fusion, go to Open, Open from Computer, select your set file we just created, and here is our board. The default thickness of this board from Kicad is 1.51 millimeters. That'll print a pretty rigid board using PLA, but we just have to be careful how tall we make our traces, as we are limited by the length of the pins from our IC, which is just a little over 2 millimeters. I found that 0.5 to 0.6 millimeters is a good amount for the traces. So to create that, we're going to go up and select Extrude, and extrude these traces 0.6 millimeters. And finally, highlight the whole thing, go to Combine, and we're done. So to bring this into the slicer, just go to 3D Print, select our component, might get this error if you're using the 3MF file, that's okay. Want to flip our print over, and before I make any changes to the settings, let's take a look at what this looks like. As you can see, we're missing some material around the holes for the components, as well as we have some voids here that the printer is not filling in. You could probably get a much better resolution if you're using a smaller nozzle. I believe mine is currently set up with a 0.4 millimeter nozzle, but we can fix this a little bit. So under quality, we want to go to the wall generator and set that to Arachne. Let's take a look. So that's filled the holes around the components, the material around the components. And then finally under strength for the top layer, for the pattern, we're going to select rectilinear. And that's going to fill in these traces much better. And that's all there is to it. So we go print plate. To add the copper to our board, I'm using this copper foil tape I got on Amazon. And I've cut a small strip off here. And we are simply going to just be pressing it onto the raised traces here. So you want to press pretty firmly. This will make cutting away the waste easier as well. You can see what it looks like now. Looks pretty good. A little bit in this groove right here. Careful not to tear it. And I'm using a razor blade. You can use X-Acto knife, anything you'd like to cut this away. And now we're just going to be cutting around the edge of the trace, using it as a guide. All of our traces are cut out. We can go ahead and remove the bulk of the foil and then come in with some tweezers and pull the rest of the pieces out. That's looking pretty good. Didn't get anything that peeled up. Might have a couple more pieces. I'll clean up this corner a little bit. So to poke the holes through the copper, it's a little difficult. They're a little too small to see from this side. So what I'm going to do is I folded up a paper towel, put this on here, and I'm going to poke them from this side. So I'm just going to go through, poke all of our holes. That's what we have. And now I'm going to go in and widen them using both the tips of the tweezers here. There are all of our holes. We are ready to add our components now. Here's the final board. Let's see if it works. Excellent. I think that turned out really nice. Here's the example board that we saw in the beginning of the video. This was my first attempt using this method, and this is a voltage tripler. When I was designing this, I didn't want to have to solder the diodes, wires, and capacitors all together, potentially having all the leads exposed upside down like this. I'd much rather prefer having everything on the bottom, like a PCB, and mounted away. I could have used something like perf board, however I'd have to drill these holes out to fit the larger capacitor leads, as well as solder all the bridges. It seemed much easier at the time to simply take the PCB file, export it, raise the traces up, and make my connections that way. If you're considering prototyping your own board using this method, here are a few drawbacks you should keep in mind. First and foremost is heat. Both of these boards are printed with PLA, which has a very low melting temperature. Soldering to them isn't an issue with a hot iron, as you can quickly make these connections without melting the PLA. However, desoldering would most likely ruin these boards. A second consideration is flexibility. These boards are not very rigid. While this isn't always going to be an issue, it's something you should definitely consider in your design. Another way to mitigate these drawbacks is to use a higher temperature filament, such as ASA or ABS. Hopefully this prototyping method is useful, and I'd love to see what you guys come up with. Thank you for watching.